Welcome to Module 4, Learning Objective 4, where we're going to distinguish between nominal and real GDP. We're going to explain the difference between nominal and real GDP, calculate real GDP given nominal data, and define the GDP deflator, and lastly, calculate the GDP deflator. So we've got a lot to do, so let's go ahead and jump right into it. The first thing that we as economists want to understand is there are two different types of GDP. When people talk about nominal GDP, this is the final output of all goods and services produced within a country within a given year, but nominal GDP includes inflation. And so it gives us a very different perspective of economic growth. What we like to do as economists is we like to deal with this idea of real GDP. And real GDP is actual GDP. So here's an example. Imagine that in 2014, you purchased a dozen eggs. And we know if you purchase a dozen eggs, you get 12 eggs. And let's just say that those 12 eggs cost you $3. In 2015, you also purchased a dozen eggs, so you still get 12. But the price went up to $4. Now, in valuing this in nominal terms, it looks like the price of eggs went up by $1. And that might be true. But if we're valuing eggs, it almost looks like the value of eggs is greater in 2015 than it is in 2014, meaning that this dozen eggs is more valuable in 2015. Well, it's not, because you still get just 12 eggs. So because GDP looks at output, we're not producing any more eggs, but the valuation of those eggs has went up. And that's why it's important to only use real GDP when we're trying to determine if there is a substantial growth in the economy. Because again, final market value, and again that market value, did the market value actually go up, or did inflation increase, which is making it look like the output went up? So that we have to differentiate between the two, and that's a really important topic in this particular chapter. Let's go on. So here's an example that we have. We have some different years, and we have just two goods in this economy. We have pizzas and lattes. And we can compute the nominal GDP. So what we're doing is we're just simply taking the price times the quantity of each item. In this example right here, it's the pizzas. Okay, and so we just brought those down. And then we take the price times the quantity of the opposite good, lattes. Notice that we're just simply multiplying the prices and the quantities. And that gives us nominal GDP because we haven't adjusted for inflation. So this is nominal GDP. And we see that it's 6,000 in 2011, it's 8,250 in 2012, and 10,800 in 2013. If we were silly enough and didn't have an econ course, we would then, or what a lot of people do, unfortunately, is calculate the percent change. So if we looked at the percent change, which would just be simply the 8,250 minus the 6,000 divided by 6,000, again, make sure you do your numerator first, multiply that by 100%, it looks like we had a 37.5% increase in our economy and then a 30.9% increase. This would be incorrect because we don't know if this is a real output of pizzas and lattes, if they really grew that much, or did the price levels rise that much. So what we have to do is to adjust nominal data, and we have to take that data and then convert it into what we call real data. Strip out the inflation, if you will. So to do that, to strip out inflation, what we're going to do is choose a base year. And the base year is always the first year that you're given. So for you, because you're only going to be given a small data set, it's always going to be the first year. So always remember you want to hold prices constant in the base. And so that's what this illustrates right here. By this box, we're holding the price constant in the base year. So what we do then is we say, okay, if we hold the prices constant, then we can evaluate whether this quantity really did increase or not. So we're just holding inflation constant in the base. So now we have price in the base times the quantity, and then price in the base times the quantity. And notice where it gets really different. In your first year that you're given, you're always going to end up with the same number because it's the price that you're using in the base year. Where it gets different is in 2012, what we're going to do is we're going to use $10 from our base year, multiply that by the 500, and add that to $2, again using Latte's base year price, times 1,100, and add that together. And when we do that, we get 7,200, okay? And so at this point, what we want to do is to, there we go, that's a little bit better. So what we want to do is see the difference. Now we can, and it is appropriate to calculate the percent change. Remember, percent change is just your most recent. So in this example, how did they get 7,200? Well, what they did was they took 7,200, again, price times quantity in the base, and how did they get the 20% increase? They subtracted 6,000, the base year. Again, they did this part in the numerator first, divided by 6,000 times 100%, and that's where we got that 20% from. And then we did the same thing for 2012 to 2013, but now we would use 8,400 minus 7,200 divided by 7,200, again making sure you do the numerator first, times 100%. And that's how they ended up with this 16.7. A very different perspective than what we had when we used nominal data. So economists always want to strip out the inflation from the GDP numbers to ensure that we're dealing with real growth. Okay, so this slide just kind of sums it all up. What was the differences that we saw? Notice that nominal GDP makes it look like there was a lot of growth in this economy. But in reality, that growth is not growth at all. It's a simple rise in the price level over time, which we would say is inflation. The real GDP really does depict the actual output growth. So the actual growth in this economy. So that's why we always want to make sure we use real data. Okay, so this particular slide again just says, hey, look at these percentages. They're very, very different. And again, the differences in these are due to inflation. But we want to make sure we strip out all inflation, and we definitely, given the choice, would like to see real data as opposed to nominal. This chart just basically depicts the differences between real and nominal data, and I often ask students, what do you think the difference between these two lines are, between the blue and the red line? And the right answer is, well, that must be inflation. Okay, so the difference between the real GDP and nominal tends to be that inflationary component. Now, one way that we can measure inflation, it's not the best measure, but it is one way to measure inflation, is called the GDP deflator. And the GDP deflator is kind of the last step after we calculate nominal GDP, real GDP. What we can do, because we have both pieces of information, we can divide nominal GDP, again, the stuff that has inflation in it, by the stuff that doesn't, real, okay? So we could say it's deflated if you'd like. I mean, that's one way to look at it. And there we go. Okay, that's a little bit better. All right, so we could take the deflated data here, okay? And then if we calculate this, we're going to end up with a percentage, and that percentage is an indicator of the inflation rate. It's not the best one to use. We'll look at that one in the next module, but it is a pretty good indicator. So here's an example basically looking at calculating the GDP deflator. So where did these numbers come from? If you just look down here, again, nominal. Okay, so remember it's nominal divided by the real will give us time, then multiply that answer by 100% will give us the GDP deflator. Also notice the GDP deflator is always going to be 100% in the base year, and that's because we're expressing all prices in the base year. In this example, that base year is 2011. Okay, so now it's time for us to try our hand at this, and so we're going to go ahead and do that. So it says compute nominal GDP in 2011, compute real GDP in 2012, and then compute the GDP deflator in 2013. So I'm going to go ahead and minimize this slide now that I've learned how to do that. Let's kind of minimize it and move it over here. And we'll go ahead and solve each of these problems one at a time. So compute nominal GDP in 2011. So remember, nominal GDP is just price times quantity. So I'm going to say nominal is equal to price times quantity plus price times quantity. So I'm going to go ahead and do that for 2011 because that's what they're asking me for. So notice the setup here is a little bit different. The goods are now over here in the rows, and the prices are up top. So I want to make sure I stay in the right year. So for 2011, I'm going to say, okay, we have good A, and the price is $30 times 900. Okay. And that gives us 2,700 plus the good B, which is 100 times 192, and that gives us 19,200. Okay, and if I add those two, that's wrong. Okay. What I want to do at this point is to go ahead and work this problem for you, and we're going to go ahead and solve this particular problem. Notice the setup is a little bit different. Sometimes that throws even me off. And so we have the base year of 2011. They told you to use that as a base year. We have good A, price and quantity, and then we have good B, price and quantity. So I'm going to go ahead and minimize this. Now that I know how to do that, so I'm going to just minimize that over here, and we'll just go ahead and work each of these one at a time. Okay, so the first step I'm going to make is I am going to go ahead and compute nominal GDP in 2011. So we have nominal GDP. Okay, and remember nominal GDP is just price times quantity plus price times quantity. I should put a plus a little bit better there. Okay, so I'm going to go ahead and do that for 2011 because that's what the problem's asking me to do. So in 2011, I have $30 times the quantity of 900 for good A, and that gives me 2,700. And then price times quantity for good B is $100 times 192, and I just looked at this and I think I missed a zero. How about 27,000? That sounds a little bit better. 100 times 192 gives me 19,200. And if I add those two together, then I get the nominal GDP of 46,200. So our answer to compute nominal GDP in 2000 is 46,200. Okay? I'm going to go ahead and erase this bottom part here. And we'll go ahead and erase that. Okay, I want to erase that too. Okay. So let me just rewrite that, 46,200, because we might need that later on. I don't think so, but We just want to make sure we're right. Okay, second question says compute real GDP in 2012. So now I'm going to look here in 2012. Okay, now remember in real GDP we have to hold the prices constant in the base, which means that we're going to continue to hold the price at $30 and $100. So let's go ahead and calculate the real GDP in 2012. So I'm going to take again my price in the base, which is going to be $30, times my quantity in 2012, 1,000. And I'm going to take my price in the base of good B, $100, and I'm going to multiply that by the quantity in 2012. Again, remember I'm holding the prices constant in the base so that I deflate this. So 30 times 1,000 is 30,000 plus, and over here I have 20,000. And so the real GDP in 2012, adding those two together, is 50,000. So that's our answer to part B. It's 50,000. Okay? Let's go ahead and erase that portion as well. Okay. Just this. Let's see, let me just do that. Probably not. How about I just use my little handy dandy eraser here? That might work for me. Okay. There we go. There's my handy dandy eraser. Oh, that doesn't want to work for me either. Oh, this is great. I'm just really cooking with butter here. Okay, so we're going to go ahead and erase that. And so I'm just going to rewrite what we had. We had 46,200 and we had 50,000 there. Okay, compute the GDP deflator in 2013. So now what we have to do is to go ahead and compute nominal GDP in 2013, real GDP in 2013, and then use the GDP deflator, which is nominal GDP divided by real GDP times 100. Okay, so let's go ahead and do that. So in 2013, we have our price. We're going to do nominal first. Okay, so we're going to take the prices that are given in the problem. We're going to go ahead and use this because it's nominal. Okay, so nominal, we want to go ahead and use that. And so in nominal GDP, we're going to take 36, because that's our price, times our quantity of 1050, plus our price 100 times our quantity of 205. Okay, so 36 times 1050 is 37,800, and we have 205 times 100 is 20,500. If we add those two together, we end up with 58,300. Now remember, that's nominal. Okay. Now the next thing we want to do is to go ahead and calculate the real. And when we do the real, we have to hold the prices constant in the base. So for the real GDP, we're going to go ahead and say, okay, 30 times, and the quantity of 1050 remains. So I'm going to say 30 times 1050 plus 100 times 205. That's kind of nice. That didn't change for us. So I already know from the previous problem that that's 20,500. And now I'll calculate 30 times 1050. And that gives me 31,500. 31,500 plus 20,500 ends up being 52,000. And that's real GDP. At this point now, I can go ahead and, let's see if this works pretty well. And I can go ahead and complete the GDP deflator. So remember, the GDP deflator is nominal divided by real times 100. So I'm going to take my nominal GDP of 58,300. I'm going to divide that by my real GDP of 52,000 and multiply that by 100. And when I divide nominal divided by real, I get 58,300 divided by 52,000 ends up being 1.12, and I'm going to multiply that by 100, and that gives me 112.12. So what exactly is 112.12? Well, we would call these basis points, and it basically says that from 2011 to 2013, the price level, or inflation, increased 12.12%. Now again, best measure of inflation, no, but it is one possible measure that we can use. How did I know it was 12.12%? Because if you look at basis points, they're always expressed in 1/100th of a percentage. So when I look at this, I can say, okay, if I strip off the 100, I am left with 12.12. Many times in like CNBC and so on, they will talk about the idea of basis points, and that's what this basically means. And we can interpret it because our base year was 2011. That's why I said inflation was over that time period, because they asked me for the GDP deflator in 2013 using 2011 as a base. Okay, in this one we can just check our answers. Yeah, we got 46,200. We got 50,000. Looks like we were. And let's see, we got 112.1. So inflation grew 12.1%. And so that's kind of exactly what we had. So that's good when you work it out that way. Again, if you have any questions, please don't hesitate to contact me on the material. Have a great day. Thanks.